All right, so we're going to talk about percentiles, and a lot of you all have seen percentiles before. If you took the SAT or the ACT, when you got your score, there was a percentile associated with it, right? Like if you scored 700 on the math SAT, your percentile was probably around 90%, meaning that you scored better than 90% of the people who took the SAT math portion for that particular year. If you're a parent, when you get your child at the well visits, they'll give you your height and weight, and they also will give you percentiles. Like one of my children was always 95th percentile for height, or further out, meaning that he's taller. He was taller than 95% of the kids his age. And the other one was lucky to stay about the 10th percentile, meaning he was taller than 10% of the people. So percentiles are measures of location that divide your data set into groups. 60th percentile is a data value that has 60% of the data values less than or equal to that value. So if we have a random sample of FICO scores, and I did already put them in order here, and we say, okay, well, what's the percentile for this data value of 789? Now, the book is horribly unclear here, and don't worry, I don't normally test on percentiles, only on quartiles. But I think there might be a homework problem or two on this. So what's the percentile for the score of 789? What we're going to do is count the number of data values that are less than that number. So 1, 2, 3, 4, 5, 6, 7. That's going to be X, so 7. And 789 that's not repeated, so that's going to be Y. That's the number of values equal to the value we're looking at. So 0.5 times 1. And we're going to divide by the total number of data values in the set. So 7, we've got 8, 9, 10, 11, 12. All right, so we're going to calculate 7.5 over 12. That is going to be our percentile. So 7.5 over 12, so 62.5%. So not too bad here. All right, we're not going to do the 60th percentile. Now, because this is a very small data set, you might get like that 789 is technically, if you back it out the other direction, you might get multiple percentiles for the same value. So for instance here, we're going to do the value of the 70th percentile. So what we're going to do, K is our percentile. So we've got 70 over 100. N is our sample size, so that's 12. And then we're going to add 1 to that. So I'm doing 12 plus 1, which is 13, times 0.7. And that's going to give us a position. So let's go here, move, whatever. So we said 0.7 times, nope, 0.7 times 13. All right, so that says 9.1. Okay. So basically the low-tech, if this had come out to be a whole number, if it had come out to be 9, then our 70th percentile would be 802, right? But since it came out to be 9.1, what we're going to do is we're going to average the 9th and the 10th data values. And so this here is for small data values, small data sets is really not an exact value. So we're going to average 802 and 818, and we're going to get 810. All right, and that's going to be our 70th percentile. You can do the same thing for 60th percentile or any other percentile that you like. It's just like that. So, but this is just really to bring us into, one, the idea of a percentile, because once we get into chapter 6, we're going to find it a little bit different way, because this is only for data sets, samples. In chapter 6, we're going to take this idea to populations. But we're interested in a particular percentile, which is the quartiles. Again, these are measures of location. And they're going to divide our data set into 4 quarters, 4 groups. So each one of them is 25% of the data. Our first quartile is going to be called Q1. So if you imagine this is our data, it's all lined up in a row. Now, of course, the middle is the median, right? And that divides the data into the lower 50% and the upper 50%, right? Now, so if we take that bottom 50% and we divide it into half again, that is going to be our first quartile, Q1. And there, we're going to have, so that 50% gets split in half. So we've got our bottom 25%, our second quartile, and then if we take the top 50% and we divide that into half, that's going to be Q3. We have 25% here and 25% there. So Q2 is really the median, okay? We don't call it Q2, nobody does. So the third quartile, the first quartile separates the bottom 25% from the rest, the top 75%. And Q3 is going to separate the top 25% from the bottom 25%. So they kind of go opposite there. So there's several different ways to calculate these. I think I have taught at least 3 different versions, and then the computers calculate it differently, which is why I always have to go check what book I'm teaching out of. So we are going to use the method that's in the book, where it is not very clear in the book. We will find the median of the lower half and the upper half, not including the median. Okay, so we're going to separate our data into the bottom half and the top half, but if the median is one of the data values, we do not include that in our bottom and top halves. And then you just find the median of the bottom half, that's Q1. You find the median of the top half, that's Q3. So on exams, homework, and quizzes, you should be calculating those by hand unless it says use Minitab or GeoGebra. And if it says use Minitab, you can use GeoGebra, it doesn't matter. Okay, so we're gonna do quartiles and interquartile range together. So that distance from Q1 to Q3, let's do it in green. This distance is called the interquartile range. This is the spread of the middle half of the data. All right, so there it says middle 50% of the data. How spread out that is the interquartile range. Very simple to find. It's just Q3 minus Q1. And it typically pairs with the median. Okay, median is very resistant. The interquartile range is very resistant because it is only looking at the middle 50%. It doesn't care what's going on up here or down here. So long as they stay in their lane and stay at the bottom quarter or the top quarter, it doesn't care. It's not going to affect the spread or the variability of the middle 50%. Okay, so it's very resistant. All right, so we're going to do an example and then we'll break it to the next video. All right, so we've got a random sample of FICO scores here. Let's see, how many do we have? 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. And thankfully, I put them in order already, right? So that there's 12 data values. So our median, we'll start off with that one, will be in position 12 plus 1 over 2, 6.5. So our median is going to fall right between the 6th number and the 7th number. So we've got to average those two. So what do we got here? So clear, 753 plus 779 divided by 2, 766. So median 766. Now, what we're going to do is we're going to say, okay, this is my dividing line between the 6th and the 7th number. So everything, sorry, let's do highlighter. In the bottom half, I need to find the median of that, right? So that's going to be my Q1. So Q1 is the median of the bottom half, and we can say right away, okay, there's 6 data values. What's the middle of the 6 data values? It's halfway between number 3 and 4. So that'll be, let's see, 698 plus 714 over 2. And we've got to pull, because these are even numbers again, clear. All right, so 698 plus 714, so 706. And then we're going to do the same thing for Q3. We're going to go highlight in a different color. Here's our top half of the data. And we've got, where's our median going to fall? Our median of the top half of the data. It's going to fall between the third and the fourth data values in the top half. So it's going to be the average of the 9th and the 10th data values, 802 and 818. So that's going to be 810 for my Q3. Okay, so that wasn't too painful. And so the only thing is, if this had 13 data values, then our median would actually be that 779 or whatever the number is in the middle, and it really wouldn't impact our Q1 and our Q3. So our interquartile range is going to be our Q3, 810, minus our Q1, 601, and that's going to be 104. So that's a pretty simple calculation. Okay. Now what happens if the lowest value is changed to 500? So this person didn't pay their bills, right? Their credit score dropped like a rock. Does that change the median? No, because none of the data values changed order, right? That 500 was the lowest, the 664 was the lowest value. It's still the lowest value at 500. Median just cares that 6 values are below, 6 values are on higher than it, sorry. And then Q1, same story, right? The median of the bottom half, it didn't change. Median of the top half, it didn't change. So no change to the interquartile range, which is nice. It's because it is resistant. Okay. And last part of this, and then we'll break for the next one. What is the 5-number summary? So the 5-number summary, I'm kind of at the bottom, I'm going to have to write it here. 5-number summary, put 2 M's in there, is the min, the Q1, the median, the Q3, and the max. And this kind of paints a picture with just 5 numbers, no matter how big your data set is. So let's go back to the original data, 664, and then 706, 766, 810, and 836. So from those 5 numbers, you have a measure of center with the median, you have, and you have 2 measures of spread. You have the interquartile range, you can calculate Q3 minus Q1, and you have the range, the max minus the min. Okay. So that's it for this one.